The curve C with the equation y equals x times 4 minus x intersects the x-axis at the origin and at point A, as shown in the diagram above. At the point P on C, the gradient of the tangent is minus 2. Part A, find the coordinates of P. So P is where the gradient is minus 2. We need to work out where that is. So the moment it's talking about gradient, I'm thinking I need to differentiate. But the way this is written at the moment is not particularly convenient for me to differentiate, so let me expand those brackets. So x times 4 is 4x, x times the minus x is minus x squared. That now looks easier for me to differentiate. The 4x is going to differentiate to be 4, the x squared is going to differentiate to be minus 2x. So this is my gradient function. And I'm trying to find when does that equal minus 2. So let's put that equal to minus 2 and solve it. So if I take the 4 away from both sides and divide by minus 2, I find that the x coordinate of P is 3. To get the y coordinate, let me substitute that in here and here. So 4 times 3 is 12, take away 3 squared, so take away 9. 12 take away 9 is 3. So the coordinates of P are 3, 3. The region R enclosed between the curve C and the line OA is shown shaded. We need to find the exact area of R. So to work out this area R, this is the area between the curve and the x-axis. So we can actually integrate here. This is going to be equal to the integral of my y function with respect to x. The y function is x times 4 minus x, or remember we expanded that out to be 4x minus x squared. So that's a bit easier for me to integrate. Our lower limit of integration is 0. The upper limit of integration here, I'm not sure what that is at the moment, but I can work that out because I know at this point here y is 0. So let's take my y function, the x times 4 minus x, and when does that equal 0? Well, it equals 0 at 0, according to that, which we already knew here, or according to the 4 minus x here, when x is 4. So my upper limit of integration is 4. Right, let's integrate. So the 4x, so we're going to add 1 to the power, so we'll get x squared now and divide by the new power. The minus x squared, again, we'll add 1 to the power. So we'll get an x cubed, divide by the new power, 1/3. Before I substitute my limits in, I can just do a little bit of simplification here. The 4 divided by 2 is 2. Right, let's substitute the limits in. So first of all, substituting the 4, we get 2 times 4 squared minus 1/3 times 4 cubed. Substituting the 0 in, we'll get 2 times 0 squared, which will be 0, and the 0 cubed is also going to be 0. And simplifying that then, the 2 times 4 squared minus 1/3 times 4 cubed gives 32 over 3. And that's how I'm going to leave my answer in its exact form.